Hello everyone, it's Benny, and welcome back to the 3D software rendering tutorial series. Last time, we managed to finally stop having a boring, flat, white triangle on the screen, and now we're having color that's interpolated across the face of the triangle. Which is better, but wouldn't it be nice if we could just draw an arbitrary bitmap and just draw a texture on the triangle? And that is the topic of today's video. Today, we're going to implement a basic form of texture mapping known as affine or linear texture mapping. So, let's go ahead and let's get started. So, the way this works is actually rather simple. Let's say this is our texture. It's our big grid of pixels. You can obviously have whatever colors you want in here, but yeah, that's what texture is. It's just a big grid of pixels. And we're going to represent locations in this texture in a sort of normalized coordinate system. So rather than 0 being the start and, say, whatever the texture height is being the top and whatever the texture width is being the width, we're just going to represent everything in 0 and 1, where 0 is the start, 1 is the top on Y, 0 is the start on X, 1 is the right on X, and so forth and so on. So yeah, that's how we're going to represent our texture coordinates. So we have a texture, it's in some normalized coordinate system, and we have our triangle with all our XYZ 3D vertices that make it look so 3D and whatnot. So how do we get part of this texture drawn into this triangle? I mean, the texture is square, our triangle is, well, a triangle, so how's that going to work? It's actually going to be very simple. What we're going to do is we're going to have a second triangle inside the texture. And each vertex in this triangle corresponds to one vertex in our real 3D triangle. And all we're going to do is we're just going to map the section of texture that's inside this texture coordinate triangle into our real 3D triangle. And it's that simple. That is affine or linear texture mapping in a nutshell. So let's go ahead and let's implement this. It's really that straightforward. So first off, we're going to change our vertex class. We're not going to have mColor anymore, but we are going to have mTextCoords. So we have position and text coordinates at every vertex. And I'm going to change getColor to getTextCoords. So there. And I'm going to change this to take in a vector 4 of text coords, and mTextCoords, of course, is going to equal text coords. And that's all we really need to do in here. Now, in the edge and the gradients class, we're really just refactoring the exact same code we had with color to use texture coordinates. So in light of that, I've done it off screen. The only thing that makes this remotely different is rather than doing it with a vector, I've decided to split up just the X and Y components into individual floats. That's the only difference. The code and logic is exactly the same. So, if we scroll down, you look at this, mTextCoordX doing the exact same thing as, well, as we did with color. The only real difference is, again, it's split into X and Y stuff, and I can now use directly, like plus sign for add addition, asterisk for multiplication, because this isn't a vector class anymore. And yeah, so exact same logic, just, well, split up into the two components. And there. And gradients, same sort of thing. Whoop. Same sort of thing. We're splitting it up into a textCoord X and textCoord Y array. We have textCoord X step, textCoord X Y step, just like before, and textCoord Y X step, textCoord Y Y step. I'll admit that's a little bit confusing with just the naming conventions I've chosen, but, well, I figure it's important to stay consistent now, so there you go. But yeah. And again, same sort of things, just split into X and Y components. So, same thing here, over here, again, same thing, just split into x and y components. Here, same stuff we did before, just split into x and y components. Oh, and of course we can use asterisks for multiplication, minus signs for subtraction and such, because these aren't special classes anymore, they're just floats. And there, that's all there is to edges and gradients, just a little bit of refactoring. Takes a while, so I don't really want to show it on screen, but hopefully that makes sense to you. It's really the same thing, just refactored and split into two components. So, finally, we can get into actually doing some texture mapping. Now obviously this means changing our fill triangle function to have a new parameter for Bitmap Texture. This is the texture we're going to draw on our triangle. And this is sort of going to need to be passed down through the whole sort of chain here. So, scan triangle, yeah, this is going to need to know about the texture too. So, yeah, that'll need to know about texture. This will need to know about texture. So, yeah. But the good news is, whoops, Bitmap Texture is passing in texture. Bitmap Texture goes here. But the good news is, we really don't need to do anything special with it. It really is just passing it through all the calls. Let me just make sure I did everything correctly. Okay, that looks correct. If not, the compiler will tell me. So with that, we can start fiddling around with this a bit. So, I'm going to have some float text coord x that will equal gradients dot, left dot get text coord x, and a float text coord y. So now it'll be the same sort of thing. Left dot get text coord y, and just like before, we're going to add gradients dot get text coord x step times x pre-step. It's a little bit different with using symbols rather than methods, but there you go. And here we'll get text coord y x step times x pre-step. And there, so these are our text coord x and text coord y. And at the bottom, we're just going to say text coord x. I'll just do one line first. Just say that plus equals gradients dot get text coord x step. And yeah, so, and whoop, not shift delete, text coord y, get text coord y x step. And there you go. So now we have valid texture coordinates at every pixel. All we really have to do is read that from the texture. And that sort of leaves a question. How are we going to take our bitmap and read one pixel and move it to another? And the way I'm going to do this is with a new method. What we're going to do is we're going to have a new method a lot like drawPixel, but instead this is going to copy a pixel from some other bitmap into this bitmap. So I'll also have int source x, int source y, and this is and also a bitmap for the actual source. And we're also going to rename x and y to dest x and dest y, just for clarity's sake. So let's go ahead and do that. So dest x and dest y. I'll rename this dest index again for clarity. So there, and let's copy this. And we're going to have a source index. This is going to be the location in the source bitmap we're copying from. And source.getWidth, be careful about that. And in components, it's going to be based on dest index, so we can go ahead and change that. So there. And now, we can just say source.getComponent, which I'm pretty sure exists. No? Okay, well, I'll create it then. Public byte get component at int location, int index, sure. And that will return in component subindex. There we go. Pretty simple. And with that, all we have to do, say source get component at source index. There. Simple as that. We just need to do that same sort of thing for R, G, B, and A. So, well, in that opposite order. So +1, +2, +3. There we go. And also we need to rename the method. So I'll say copy pixel. Sure. That works for me. So there we go. We now have a method that will copy a pixel from some other bitmap. So now we can actually go in here and start, well, just copying a pixel from the other texture. So I'm going to comment all this code out. I'm going to leave it around just in case we need some of it. Because what I'm going to be doing is I'm going to be saying int source x, because we're going to have to apply our fill convention here. So this is going to, of course, start with text coord x. We're going to multiply this times source.getWidth. And actually, or is that going to be source.getWidth minus 1? Yeah, this is actually going to be source.getWidth minus 1. Excuse me. Sorry about that. And there, this will give me a value between 0 and source width minus 1. I want to add 0.5f so it rounds properly. And then I think I can just cast it to an integer. So, there, I'm pretty sure this will do what I expect. So there's text coord y, or, yeah, there's source x and source y. So all we have to do now is say copy pixel to x and y from source x and source y, and using our texture as the source. So this should be all we need to do to change our drawScanLine method to use texture mapping. Okay, and I just made a few small typos. For instance, this should be texture, not source. In vertex, it's important to remember to change this to mtext coords and this to mtext coords. There's just a few minor things like that. Other than that, I did set up a basic example. So I have a bitmap texture. I'm just randomly generating pixels right now in a 32 by 32 fashion. And I also changed my text coords here. So first is 0, 0, then 0.5, 1, and then 1, 0. So that's sort of consistent with our vertex positions. And also, fill triangle, has in texture. So I just set up the example stuff off screen because I figured, well, that's not that important. So if we build and run, look at that. We have a random texture being drawn on a triangle. And there you go. That is unmistakably texture mapping. But you might notice it looks like it's working, but it looks a little bit off somehow, in a way you almost just can't quite put your finger on. What is that? How can we deal with it? Find out next time on the 3D software rendering tutorial series. Hope you enjoyed, hope you learned, and I'll see you then.